It's okay, Professor. The microphone is yours now. You can continue your presentation. Thank you a lot. Please go on.
I thank you so much. Thank you so much. Hi again, dear participants. My name is Osman from Bilecik Şehrbali University from Turkey. Before starting my presentation, I'd like to make an explanation. Normally, this work would be presented by Metin Tugay, one of the collaborators of this work. But since he got COVID and have some health problems, as one of the co-authors from of this work, I will talk about today for you. The main topic is approximation properties, approximation behaviors of generalized sampling series and sampling Kantorovich, especially sampling Kantorovich operators, such as pointwise and uniform convergence properties and rate of convergence, and a Voronovskaya type formula are the main titles of this presentation. Let me talk about something in introduction. Sampling operators are very useful tool in order to provide an approximate version of the classical sampling theorem. This version mainly depends on generalized sampling series defined by in the equation 1, as you see. Here, f is a function from R to R, and G is the kernel function. Satisfy some certain condition. Here we show the relation between the generalized sampling series and their Kantorovich forms. How we construct this relation, you see on the page. This is the page why we use generalized, why we use sampling Kantorovich operators in weighted spaces. Because we are enlarging the class of functions instead of the space of uniformly continuous and bounded functions. So this is an important step. Okay, let me give you some basic definitions and notions about the study. Firstly, I want to give the definition of the kernel, which we use very much. A function G is from R to R is called a kernel function which satisfies some certain conditions, G1, G2, and G3. These are about absolute and algebraic moment of this kernel. And here is a useful lemma we use in the main theorems. As you see, there is a limit here, and this limit goes to 0 if the kernel satisfies G1 and G3 conditions for every delta when is bigger than 0. And here we have a condition also such that absolute moment of G is finite. You see, it's finite. And the definition of weight function, it is also very important concept for our study. Here, the function omega tilde is called a weight function. On the whole real axis, it is continuous, of course, and positive. We consider our weight function as 1 to 1 plus x square, as you see, where x is a real number. And here you see some related function spaces in weighted function spaces. And the norm of about the space. Okay, let's continue. Here, again, there is an important concept for us, modulus continuity, weighted modulus of continuity, and the definition of is given in five, as you see, and some properties about weighted modulus of continuity was given in this lemma. As you see, it is monotonically increasing function of delta. There is a limit goes to 0, and there is a special inequality. In this remark, using the inequality 6 with lambda, taking absolute value of y minus x to delta, we can get an other inequality in the bottom of the page. You see, we use this in the next page. Especially in the details of the proof. A useful result for us. If we choose delta less than 1, then we obtain this inequality difference between fy minus fx. Okay, let me go on. Let's give the main results. Here, there is a theorem shows us generalized Kantorovich operator is a linear operator. And the form of the norm of operator. And the details of the proof here. I will skip these pages. Okay. The main theorem of this section can be stated as follows. Convergence results are given, and we omit the details of the proof. Okay, let's talk about rate of convergence for our operator, Kantorovich operator, via modulus of continuity. To do this, we need to give a lemma. Firstly, this lemma gives us some results about weighted modulus of continuity. Here are some results. Here is one of the main theorems of this section, helps us considering the rate of convergence. And this is another one. Yes, this is another main theorem. Determines an upper bound for difference between the operator k and function of f. The next theorem determines an upper bound for difference of operators, generalized sampling operator and Kantorovich operator, and presents us an estimate for difference of the operators. Now, I want to show the Voronovskaya type formula, but firstly, I need to give the definition of algebraic moment and algebraic moment of order J of a kernel G by small m G, as you see, the definition. And we also need these two extra conditions on our kernel, varphi 4 and varphi 5. Now, let's give the definition of the known Taylor expansion with its remainder function. Here, we give an estimate about the remainder, which is given in 16. And here is our Voronovskaya type formula. Yes. And these are our references which we used in this work. Thanks for your attention.
Thank you very much for your extremely good talk, Professor Osman Alagoz. Is there any